This is Harvard on the Map, presented by the Harvard Graduate School of Design, covering innovative ideas and thought leaders in digital cartography, Earth observation, and all things geospatial, with your host, Jennifer Horowitz.
So welcome to Harvard on the Map. I'm here with James Wu, who is the CEO and co-founder of DeepMap. Thank you for being on the program.
Thank you for having me.
Yeah, so I'll admit this has been the highlight of my week. I've been looking forward to this every day. I have read so much about DeepMap, and I'm very passionate about digital mapping and also about autonomous vehicles. So I wonder if you can tell the listeners a little bit more about DeepMap and the work that you do.
Right, DeepMap is a company that we built. We started 4 years ago, and what we try to do is we're trying to solve the HDMap problem for the self-driving car companies. And we noticed there's a lot of rear-ended wheels all over the place, and there's a shortage of talents, resources to do it in a large-scale format. And we realize HDMap is a critical component for the safety and the comfort of a self-driving vehicle. So that's why we decided to start a company and target to solve this problem for the industry. We want to enable our customers to build their own maps, and we want to also dramatically reduce the price of HD maps that the self-driving car system need.
So one of the questions that I had as I was sort of reading to the company is, at a certain point, you expect that there'll be fewer, manual vehicles on the road, and there'll be more autonomous vehicles. So what fraction of vehicles will there need to be that are autonomous vehicles in order to prove that there is a degree of safety that's incurred as a result of having this HD mapping software enabled in cars?
So I guess, so your question's about what kind of percentage the vehicles need to be shown to leverage the HD map to increase their safety. I think this is actually already happened. It doesn't work as like using a percentage, because for the vehicle, safety is something that we just cannot compromise. Right, because you have passengers. For some vehicles, you have passengers. Their safety is very important, and also the vehicle self-driving cars are sharing the environment, the streets with other vehicles, pedestrians and bikers, all these other people, and sometimes even animals, right, on the street. So their safety is also very important. What we have noticed is actually there's a trend that there's full self-driving vehicles, like the company like Waymo try to develop. We call it level 4, level 5 type of self-driving capabilities. There's also companies like the OEMs, the car makers, like Tesla, that creating basically a L2 system or L2 plus system that still need a driver, but make the driving significantly easier or more automated, and sometimes even make it safer as well. So it's called a driver assistant system, ADAS. And for us, we believe HD map is helpful for both. First, for the full self-driving vehicles, when there's no driver needed, and sometimes even no passenger, it's just like deliver stuff, right? I think HD map is required. It's a requirement for this kind of vehicle to be able to function. Well, for L2 plus vehicles, there's like a gray area. For L2 vehicles, you don't have to use HD map, because you've got only limit to lane keeping and ACC, and this is kind of a basic self-driving capabilities. You could achieve it using non-HD map technologies, just using perception and better sensors. You can achieve that. However, we believe if you want to improve the L2 system, increase their safety and improve the functionality of their self-driving capabilities, HontheMap will dramatically improve that. Actually, I think last week, there was an article from Consumer Report comparing autopilot, Tesla autopilot, and GM Super Cruise, which they rate GM's Super Cruise system better, safer than the autopilot system. And the difference is actually Super Cruise heavily rely on HontheMap. And down the road, I mean, Tesla made a lot of progress, of course, right? But down the road, we believe HontheMap will play a critical role even for the L2 plus market, where the car makers need to define ODD, which is operation design domain. So basically, where the self-driving cars can actually safely perform driving functionalities without human interruption or monitoring. This is actually very difficult to define properly. And we believe mapping, HD mapping will play a critical role there as well.
Fascinating. I know more about the mapping side than I do on the autonomous vehicle side, but that's a fascinating insight into it. I wonder, I know that you worked at Baidu, which is a non-American mapping internet entity. So I wonder, are there certain federal restrictions or regulations that you see as currently existing in the US that are impediments to greater adoption of autonomous vehicles in the United States?
In the US, actually, there's not any regulations for HontheMap, actually. For other countries, there's some very strict regulations. For US, I think there might be some other regulations that probably should evolve or developed to help faster and safer adoption of self-driving capabilities. I think one clearly question is like, there's no clear definition of what is an L2 plus system is. There's no guidance and there's no threshold, like how do you compare these two systems? Which one's better, which one's not, right? And especially this is related with safety, I think there's might be some regulations needed down the road.
Interesting.
Right.
Oh, I wonder if you could possibly talk about your journey into digital mapping and working with spatial data. You started, I believe did you start in the United States or did you start in China and then?
Yeah, I finished my college study and then came to the US for my PhD study. I was fascinated by computer graphics, geometric modeling, and computational geometry. And then that's basically what I focus on for my PhD study. And right after I finished my PhD study, my first job was actually, I was very lucky, hired by a small startup with 2 people. And in Washington, DC, they're making a system similar to Google Earth. That's 2003, 2002. So that's where I started my journey in the mapping business, my first job. And then I was fascinated because at that time, it's almost 20 years ago, you can sit in front of a computer and zoom in out like in real time to see like centimeter features on the ground. I feel this kind of mapping technology will fundamentally change people's life, which actually it did, right? So that's how I started, but later I came to the Valley. I worked for 6 map companies, including DeepMap, right? I worked for 3 startups, 3 giant companies. I was one of the core engineer of Google Earth, Google Maps, and then I also helped Apple launch Apple Maps. I see how map from a fun project to become a necessary feature or function for web-based mapping, navigation, and then basically become one of the most important entry for mobile applications. And then create a whole new industry of location-based service. Uber, for example, is one typical such application, like ride sharing and delivery of these applications. So I was fascinated by that, but clearly there's, from my perspective, there's another revolution going on, which is quite different from before in the map industry. Before, it's usually it's humans making maps for humans to use. Even if you have like a navigation map, right? We use machines to help us collect data and make a navigation map for humans to use, sometimes for machines to use as well. However, nowadays, because of self-driving cars, I think there's a new need that the machine is going to make map and make the map for other machines to use. So that's where the revolution coming. Like humans may not even play a critical role inside this loop. Well, the map has huge amount of data that sometimes may not even make sense to humans. Right? The features that stored in the map doesn't necessarily to be meaningful for a human perception system. And they probably don't care about where the Starbucks is, right? Or when does a shop open their door, things like that. But they need centimeter level precisions and need a lot of very frequent updates. So to make sure the map is as free as possible, as up to date as possible, fresh as possible. So we see this as a huge challenge and a huge opportunity. We believe this will be a multi-billion-dollar business. It's already a multi-billion-dollar business nowadays, but in 5 to 10 years, it will be a giant business as well. So that's why we jump in and try to solve this problem.
I wonder, I have so many questions off of that, but I know that you're also a busy person, so I don't want to take up too much of your time, but I wonder also, how do you think that satellite imagery providers, I'm working part-time right now as I'm in graduate school, and I'm working for a company called Maxar, which is a satellite imagery provider. And I wonder how satellite imagery will help inform the transformation that digital mapping will have to undergo in the next decade, and how that plays a role in that process.
I think the satellite imageries and also airborne imageries played a critical role for the last revolution of a change of maps. Basically, we have actually when I joined my first company, its name was called 1 meter. Their original name is called 1 meter. The reason for that is, I think in 2002, the US government made 1 meter resolution satellite imagery usable by commercial use for public. So it's not classified anymore. Then that's immediately changed the industry dramatically. So this is also how Google create their maps. We use a lot of satellite imagery. We use airborne imagery as well. This is how Apple is making their map as well. So a lot of the map makers, they heavily depend on satellite imageries to make large scale map, high precision, large scale map, right? In the future, I think one of the challenges actually while I was working at Google and other map companies, I think the next generation map, the key challenge is twofold. One fold is like, it's probably easy to get to like 10 centimeter or 15 centimeter resolution from airborne imagery or satellite imagery. But if you want to go one level higher, one magnitude higher, like get centimeter level precision, right? A few centimeter level precision. I think the satellite imagery and airborne imagery will be a little bit challenging for them. The other thing is really the update. We need a map that's basically is alive, constantly changing, and capture the most up-to-date information. I think that's also challenging for the airborne and the satellite imagery. There's another thing is there's actually a lot of structures. There's a non-trivial problem of occlusion. First, there's structures like parking garage, underground parking structures, and there's tunnels, these kind of things that you can capture by airborne imagery. And even if you're doing this for like urban area, there's a lot of buildings. Actually, you have to have like a pretty dense coverage of the same city from different angles, and you have to fly a certain pattern to capture all these ground feature, to capture all the ground features. So I feel these kind of challenges will push the mapping industry to moving towards ground-based mapping or mobile mapping, which is using ground vehicles to do the data collection and map update. Because nowadays when you're looking at a self-driving car or just a new car, generally if you buy a new car, there's so many sensors on it. Cameras, radars, ultrasonic, and GPS, I mean everything. Right, will be also new cars in the next couple of years. No, it's already happened, right? It's already happened. There's cars with LiDAR. It's like low beam LiDAR. But in a couple of years, you'll see a lot of high-end vehicles with high beam LiDAR. It's like more like a flash LiDAR, creating an image like LiDAR image, depth image using LiDAR and camera. So we feel these kind of information is more than enough to create very high precision map using ground vehicles. And actually, if you look at my background, it's actually a map we made. It's look like airborne imagery, satellite imagery, or airborne LiDAR, but actually it's not. The whole map on my background is actually completely created by the vehicles on ground, collect the data. And we actually we also use a camera to capture the true color of the scene, so we actually can reconstruct the full 3D scene from the ground up. This will solve both the precision problem, underground problem, the occlusion problem, and most importantly, the update problem. So while I was working for Google Earth, there's a lot of people like users. We have billions of users globally, right? They often questioning if why they cannot see themselves inside the Google Earth. Right? So I can see my building, I don't see myself. I'm on the street. Some of the users don't realize this is not a live map.
Sure.
But I think one of the challenges we were thinking at that time is how can we make this kind of a update so frequently that you can actually get to some kind of a live map system. It's actually very challenging. You have to fly very frequently, and there's also cloud lighting conditions to block the view. So it's actually not easy. There was a lot of like micro satellite companies, right? They're shooting a lot of smaller satellite and taking more frequent capture of the ground, but that also suffers from a lot of the cloud and weather conditions. However, on the ground, as long as people are driving, you capture everything live. And with 5G, these infrastructure developing, base stations, you can get the data uploaded very quickly. And it's needed by the self-driving cars anyway. So when we make the map, we need to notice what has changed in the environment. And these change is actually critical for the self-driving cars to make a better decision. So that's actually one of the key applications of our high precision map is what has changed, right? And also can give the sensors, give the car a sense if their sensors are calibrated or not, or working properly or not. Because if you don't have like a pre-mapped environment, how do you know if your sensors are off? Right? Sometimes it's difficult to do that. Of course, you can do some kind of intrinsic calibration, but generally, if you have like a prior knowledge of the environment, it's much better. Yeah, I know that's like a long answer.
No, unfortunately, it has stemmed now like 1,000 more questions, which I don't want to ask you because I know you don't have all day. So I guess my 2 more questions, and then I promise I will set you free.
No problem. Take your time.
My second question. So I know that you mentioned that the rate of refresh is such an important element, and being able to see, as the environment develops and changes, being able to notice those changes. I've read a lot about how drone companies like DJI and others have started to play a role in this mapping process. And so I wondered what your thoughts are in terms of whether vehicles will lead the way in terms of mapping, or whether drones will have a role to play as well.
We actually, while I was working for other map companies, we tried drone mapping 15 years ago or even more, right, or earlier. I think drone mapping is could be useful for a lot of applications, maybe like agriculture and forest management and mining, a lot of other spaces. For self-driving cars, I think drone mapping could be useful, but it's not necessary. So if you look at our vehicles, we can already collect a lot of data just using the ground-based vehicle, and we can reconstruct the map. Actually, let me share an interesting story. There's a company, a mapping company, airborne mapping company. They actually fly big airplanes with LiDAR and cameras on it, and capture the 3D ground surface, and then sell the data set as their product. Well, one time, one of the guys reached out to me. He's like, "You guys must have been using our data without a license, probably." I said, "No, we didn't. We just everything is from ground-based sensor." And they said, "No, that's not possible, because we actually compared your map slightly with our map. It looks exactly the same, the geometry and everything." I said, no, look, we don't have roofs, because I can't see roofs from ground. Right? And he said, "Maybe you guys did some like Photoshop of the data." And I said, no, just really it's from ground. I think, so I actually thanked the person, because I think it's a great complementary to our capability and our map. But fundamentally, once you have this kind of sensors in the self-driving vehicles, why do you need a drone or any flying vehicles? The key thing is they can't keep the map up to date anyway. So that's a problem. They can potentially create a map, but the map creation is actually not the core problem. Map update and keep it update, that's a core problem of mapping.
Interesting.
Right.
So final question, and to our listeners, I highly encourage you, members of the Harvard community, to check out DeepMap and their work. I've been on a binge watching interviews with you and reading more, or listening and watching more about DeepMap. So I highly encourage members of the Harvard community to look into it more.
We actually did a case study.
Oh.
I was invited by Howard Business School, and we did actually twice a case study of DeepMap last year. So check it out. We have a very detailed report. It's a pretty amazing case study. I learned a lot from that as well. There's some very smart student and questions asked. It's very, very impressive to me. So they actually figure out a lot of the business logics behind the scene. So there's some sense, some of the business ideas we never talked about, but they seem to figure that out as well, which impressed me a lot. Wow. We didn't talk a lot of things publicly, right? But that's a very good case study. I will highly recommend if anybody interested, dig it out. It's very fascinating.
Wow, I'll certainly look into that. Yeah.
Sure.
So my final question, which I ask all of my interviews, is to describe a time where you were lost, whether that's geographically or in your career, and how you found your way back again.
Oh, that's a very good question. I actually, this is very interesting, right? So my job is, so one of the reasons I really love mapping is I very often get lost. I still remember I was one of the first, while I was still a PhD student, I spent close to $1,000 bought the first generation GPS system. It's like basically 1 month of my earnings. 1 month of my earnings get that expensive device, and I'm the only one who has that because I get lost very often. Even for some interviews, I have to like leave way sooner, way before the interview start, and I can still get lost and be late. So I hate being late, get lost. So that's actually why I get into the map industry. And I was very, very lucky. I went through the whole revolution from like paper maps to online maps to GPS system and to the mobile map. And now nobody has a GPS unit anymore, just use phones, right? So now it's machine map. So actually, once after I finished my job at Apple Map, helped them launch the Apple Map, I was not sure what else to do in the map industry at that time. I was thinking like, look, I helped build Google Maps, Google Earth. I helped launch Apple Maps, pretty much done with mapping. And actually, I was working with my co-founder Mark at Google Map Engine team, which we're actually building maps for a lot of enterprise and even countries. So I'm not sure what else to do in the map space. I actually was slightly lost at that time. I actually start to summarize what happened in my career in the map space and try to find something new. I was looking at infrastructure and deep learning and different applications of deep learning. So that's very interesting as well. And two, I was grappling into the self-driving space and help them solve the HontheMap problem. So there was a period, like maybe about a year, I was lost. I don't know what to do in the map space. But I spent quite some time looking into how to build infrastructures, especially how to build very scalable, high reliable infrastructures. Things like Google and Amazon, this kind of company use. This is one of their major advantages compared with other companies at that time. So I learned a lot how to build that during the year. Try to build, clone the infrastructure or clone how to use public cloud or other components to build a very scalable and maintainable system, large scale system. So basically, how do you leverage whatever you have outside of Google and build something that's really scalable?
Sure.
So that's actually the very good experience for me. If I don't have this kind of period looking into infrastructure, I won't have the confidence to try to build a startup building large scale HD maps, because I know it's very, very hard. Need a lot of infrastructure knowledge.
Yeah, it's interesting how it informed, your understanding of it.
Yeah.
Well, I appreciate your time and thank you so much for coming on the program.
Great. Thank you. Thank you for having me.
Thank
Really
you.
enjoy the conversation.